Hi. As Steve said, I did a lot of responsive images work, especially recently. But for the next 45 minutes, I'm going to do my best effort as to not talk about responsive images, but talk about preloaders instead. And the reason I want to talk about that is that in last year's Velocity Europe, I talked about responsive images. And as part of that, asked the audience, who knows what the browser's preloader is? And it was just like Steve raised his hand high up and saw that no one else is raising his hand, so he was like a little ashamed of that. So it was like, that made me realize that we're not talking about this stuff as much as we should. So I'm going to try this again one more time. Who here knows what the browser preloader is? OK, better. Let me just start out with a story. So once upon a time, in a land far, far away, browsers were fetching web pages. It's not a very good story. So the way they were doing that, they were fetching an HTML once the user has typed in a URL or clicked on a link. And once the HTML got there, they parsed it and started creating a DOM tree using that. And each element inside the DOM tree was created and added to the DOM. And some of them would require sub-resources to be downloaded. So once the element was created, it added the resources, the sub-resources it needed to the download queue. And then the parser just continued parsing out more resources. But unfortunately, some sub-resources are more equal than others, and some of them have superpowers. So specifically, script for script elements, the browser would have to halt parsing and download all the resources they may depend on, and as well as the script itself, evaluate them, apply them, execute the script, and only then continue the parsing work. And the reason for that is that scripts can do all kinds of crazy stuff that change the DOM tree. The result of that was an extremely slow downloading process, which resulted in a lot of frustration. Frustration from users who got used to the fact that the web is something that's inherently slow, and frustration from web developers because their sites weren't doing as well as they should. So as a community, as a web performance community, we started gathering around workarounds. Books were written. A lot of the best practices of the time and of today as well were created in order to battle this. So minimizing the number of CSS and JavaScript requests and putting scripts at the bottom so that they would not block the parser before all other resources were downloaded, etc., were all practices that were built around fighting that delay in the download process. These are still mostly good practices in today's HTTP 1.1 world, but in the pre-preloader days, the impact there was huge. It made a huge impact on the page load time and on the way the user perceived the website, because initial rendering was much faster. Eventually, around 2008, browser vendors realized that this is a problem, and each one of their own added something that I like to call the preloader, but none of them actually call it that way. In IE, it was called the look-ahead parser. In Firefox, the speculative parser. And in WebKit and in today's Blink, it's called a preload scanner. But preloader is a nicer vendor neutral term in my view, and it describes what it does. It preloads the sub-resources needed for the page. And as Steve likes to call it, it's the greatest browser optimization of all times, and I cannot disagree with that. So that's the end of the story. But I'd like to talk a little bit about what does the preloader do. So the different implementations are different, and they have slightly different architectures behind them. So most of the things I'm going to talk about are mostly WebKit and Blink oriented, because Firefox does things a little differently, but it's, at the end of the day, the result is more or less the same. So the preloader basically, even though the script blocks the download, blocks the parsing of the HTML keeps on downloading. So the preloader looks into the rest of the HTML that keeps coming in, and then detects the sub-resources needed for the page and speculatively downloads them. And why is it speculative? The reason is that the script may change the DOM so that some of these sub-resources may not be needed, or even all of them. But that's extremely rare. So it's worthwhile to just download all the sub-resources that are picked up, and then in the worst case scenario, just throw them out and download the new ones. But again, extremely rare. And the way that the preloader does that, basically I need to explain a little bit about how HTML parsing works in order to explain how the preloader, or more specifically how the WebKit and Blink preloader, the preload scanner, does what it does. So the first stage of HTML parsing is preprocessing the bytes coming in from the network, applying a char set to them, just unifying them so that the rest of the parsing process will run smoothly. Then the next phase is tokenization. So as you can see here, the tokenizer takes an HTML string and then breaks it up into HTML token objects. Each one of these objects has the tag name, whether or not it's a start tag or an end tag, and the different attributes of that tag, whether or not, also a text token. But the important thing here is that the tokenizer has no real knowledge of HTML and the rules of HTML. So can anyone tell me what's wrong with this HTML string? I'm surprised you didn't pick it up. Hmm? No. Yeah. Image, there is no closing image tag. Image is a self-closing tag. But the tokenizer does not know and does not care about that. So it just creates an add tag for image and sends it over to the parser. The parser then takes the tokens and constructs a DOM tree from them. So it first takes the image start tag and creates an HTML image element from it. But since image is a self-closing tag, the parser then applies the rules of HTML to it and just terminates the element there and does not add the div that follows as a child to the image, but as a sibling. And eventually, when the parser gets to the end tag for image, just throws it out because it doesn't make any sense. So the preloader basically comes in between these two phases. It feeds off HTML tokens, looks into them, picks up the resources that are needed from these tags that will later on become elements, and then passes the tokens on to the parser to create a DOM tree from them. So the important part here is that the preloader, mainly the preload scanner in Blink and WebKit, has no notion of a DOM tree, has no notion of nesting, but it can keep track of whether or not we've encountered a certain tag and whether or not which attributes exist inside different tags. It can ignore comments, etc. And one more thing that's important to know is that unlike the parser, which has to be on the main thread because it creates a DOM tree, the tokenizer and the preloader can be either on the main thread or off it. And for some browsers, they're off main thread, which has certain implications on what they can do or not in terms of access to the DOM itself, which they can't. So let's, again, describe why are we blocking? Why can't the parser just continue parsing along when the scripts are encountered? The first thing to know is that regarding that is that the script can rely on a certain DOM state when it runs. So, for example, this snippet of code, if you run it in a script that's in the middle of the page, the child would be added to the end of the body at that point. If the parser would continue to construct the DOM tree further, it would be an extremely racy piece of code to write. So the JavaScript relies on a certain state of the DOM, and if the DOM construction would have continued, the scripts would break. The second reason is document writes, which are bad, but they are out there. So for example, here, if we document write in start comment snippet, the entire future DOM is becomes irrelevant. We cannot continue building the DOM and then just invalidate most of it, or it would represent extra work to the browser, and it's fairly complicated. And furthermore, scripts can rely on querying the DOM for style information. So in this example, we're looking into the DOM for a certain element's width. In order to be sure that the width is consistent and not racy, depending on the network, before running this piece of script, all styles that preceded this script must be downloaded and applied. Otherwise, we would have different results for the script when it runs in different network conditions. So these are mostly the three reasons why the parser has to stop. The parser cannot just continue building the DOM. And the resources that are preloaded they vary somewhat between different browsers, but mostly for the major resources are mostly the same. So all browsers download external style sheets. All of them download external JavaScript, and all of them download images, preload images. At import is preloaded in WebKit and Blink, so Safari, Chrome, and Opera, when it's inlined. and currently not one external, but there is some work done to enable that. Firefox downloads a video poster, and everything related to responsive images, is being preloaded as in Blink, where it is supported, so Chrome and Opera, and it will be preloaded in Firefox before the features will be shipped on and turned on by default. But that leaves us with a long list of DOM elements that trigger sub-resource download, but are not preloaded. So if you're downloading images using input image or using object, that's not preloaded. Video and audio are not preloaded, but that's just because mainly it doesn't make much sense to preload them. But for iframes and the new HTML imports, this is something that probably should be preloaded, in my opinion, but currently isn't. Another type of resource that's not preloaded is everything related to CSS-based resources. So at import, when it's external, is not currently preloaded, or even internal, not preloaded in Firefox or IE. But furthermore, web fonts don't get preloaded, and CSS background images are not preloaded. So if you're making a decision of putting an image as a background image instead of a content image, which you shouldn't because it's either content or not, but let's put that aside. Basically, you're deferring this image's load. Yes?
Any idea why video poster is only Firefox? It seems like an important one and an easy one.
It's because. Yeah, it's an easy one, true, but JavaScript-based resources are also by definition not preloaded. Everything you do dynamically, everything you type in .src and enter a URL there in order to download a resource, that's something that the preloader cannot pick up. So that's a disadvantage and an advantage, depends on what you're doing. We'll talk about it in a minute. Now let's talk a little bit about priorities, because the browser just picks up all the sub-resources from the page, but then since in the HTTP 1.1 world, we have a limited number of connections we can send to the server. We can open to the server, and we need to prioritize them. And even in an HTTP 2 world, we would need some priorities in order to download the important stuff first. The priorities are different between browsers, but again, the principles are mostly the same. And so the priorities are based on context, so resource type. So usually it's, from what I've seen, CSS first, then scripts, then visible images, then non-visible images. The distinction regarding image visibility is mainly Chrome, as far as I know. And then after that, everything, or web fonts are above images, but they're not preloaded. So that's a different story. In general, both Chrome and Firefox try to give higher priority to resources that are in the head section, so resources that are blocking rendering. Chrome even blocks almost all low priority resource download until all the head-based resources have finished downloading. And for Firefox, I think that it's just that head-based resources get higher priority. And if you're wondering whether or not this feature is spec'd anywhere, the answer is no. Since this is an optimization feature of the resource download, there is no API for the developer to hook into it, so there are no compatibility implications. And the fact that it's not spec'd allows browsers to iterate on priorities, on various, add more resources to the download queue, etc., at a rapid pace without going through a standardization effort in order to get consensus from other browser vendors. So browsers can compete on performance, basically. And taking a look regarding the benefits, I mean, this is all a nice story, but what does it actually give us? So I played around with a Chromium build that basically turned off the preloader and tried various sites in it. So just taking a look at one waterfall from the Boston Globe, you can see that without the preloader, there is a lot of blocking going on at the first 15, more or less, resources of the page. A lot of them are blocking the download of other ones, causing significant delay to render time. Whereas with the preloader, most of them are downloaded in parallel. And you can see that the only phase where it's blocking is the phase where it's purposefully blocking over here in order to wait for everything that blocks rendering to finish download before starting off low priority resource download. But this example is a bit extreme. This here we had about a 2 times factor. The preloader version was twice as fast in both onload and DOM content loaded times. On average, research that Pat Meenan, had run with Ilya Grigorik from Google a while ago, suggested that about 20% on average is the benefit expected, but it's 20% all across the board. So in page load time, in DOM content loaded, and in speed index. So what should developers know about the preloader? Why does it matter to you? The first rule is that critical resources must be in markup. Because as we said, preloaders don't see into JavaScript, and currently they don't see into CSS. So anything you want the preloader to pick up and download should be declared in markup, anything that can be. And with regard to non-critical resources, maybe you should most probably test it on your side, but it may be a good idea to take out non-critical resources out of markup, and specifically for JavaScript. Even though there is the best practice to put non-critical JavaScripts at the bottom, but the problem or a side effect of the preloader is that it picks them up and then tries to download them anyway. And because it adds them to the download queue, and it adds them to the download queue with a higher than images priority. So if you have critical images versus non-critical JavaScript, the browser may try to download the non-critical JavaScript first. So it may be a good idea for non-critical JavaScript to just download it dynamically after the page load is done and take it out of markup. Another example is for images when it comes to either the current lazy loading script or the various responsive images hacks that existed before native solution came to be. They were also based on taking the image SRC attribute out of markup, moving it to data SRC, etc., and then setting the SRC attribute via script in order to take these resources out of the download queue and out of the preloader's site. One more thing that no one does besides, the last time I've seen it was for, again, a responsive images hack. But you should not change the base tag after using script, because most chances are that the preloader has already downloaded resources based on the base tag. So changing it dynamically will make all your resources that the preloader has downloaded invalid. Same goes for the various commenting stuff in script, etc. Just avoid that at all costs. There is no actual reason to do that. And one more thing that's mostly frustration avoidance advice. Don't assume anything regarding the loading order. The browser can pretty much do whatever it likes in that area, so it's better to make your peace with it. A few examples I have where this assumption caused a lot of frustration was, again, from the responsive images hacks era, where people were setting cookies using JavaScript and expecting the images that the image requests that go up to the server to have these cookies on the first load of the page. And that just, it worked for a while, then it stopped working because most probably Pat has changed something in his in the priority scheme or for whatever reason. And that caused a lot of frustration and a lot of FUD regarding the preloader as a quotes that come to mind are mindless optimization, and browsers are trying to take control away from developers and stuff like that for no apparent reason. So just avoid these assumptions and you'll be all set. A second case, and one which I discussed already, scripts at the bottom, even though you put them at the bottom, they may bubble up because of their higher priority. So again, if they shouldn't be there, if they shouldn't be part of the critical page load, you may want to try to take them out of the markup. Yes?
I think it might be your assumption fail number one, but can you talk a little bit more? So obviously when you preload something early, and then cookies can change during the process of loading a page.
Yes.
When you subsequently fulfill the browser request for that preloaded one, it basically was fetched with the wrong cookies. Has that created problems over the years? Just compatibility issues, the site's breaking, or if I fetch avatar.jpg and that depends on my cookies, and I set that cookie during the loading of the page, I'll get a different avatar.jpg.
My guess is mainly you shouldn't do that. I'm not aware of any compatibility problems because of that, but there is no contract that the cookies coming in are going to be immediately applied to everything from then on that's going to be sent to the server. And they can come in after I mean, it's racy by definition. If you're sending the cookie down, the response, you cannot predict when would the cookie be applied. So basically for cookies, it's for, yeah, the next page load will have them for sure, but until then, there is no contract as far as I know.
Set them on the response headers and they're fine because they're guaranteed.
On the HTML response headers. But if you set them on,
So if you do a preload, and then you fetch, you do a request that says cookie, and then you...
Right, no, you have to set it on the HTML response header.
yeah.
Any other resource, don't count that you'll be able to set cookies from any other resource or script on the page before things get fetched.
Yeah, so if you want cookies, you set them on the HTML, or you expect them to be there on the next page load. One more thing. If you have critical hidden resources, use APIs that expose these resources to the browser, that add these resources to the download queue. So one of these APIs, I'm mainly talking about fonts because for everything else, you can just add it to markup. But fonts, because of their nature, have to be, basically the browser has to download the CSS, detect a font there, apply the CSS to the constructed DOM tree, find an element on the tree that uses that font, and then, and only then, it can download the actual font. If the explanation sounds long to you, it's because it's a long process. So this is the reason why we're always seeing blog posts and stuff, other sites with text, a lot of text content. On mobile, just the site has finished downloading, but the font is not yet there. So we're waiting, seeing a blank screen. And that's obviously a bad user experience. So we should try to kick off font loading as soon as possible. So one new way to do that, which it works in Chrome since 34, 35. I'm not sure it's implemented elsewhere, but it's a standard, and it will be implemented at the very least soon. But a way to do that is just to declare in an inline script, declare the fonts that you know are going to be needed for the page, and just tell the browser to load them. Yes? Oh, 5 minutes.
Is that similar to old style image preloaders?
What?
The technique there is like old image preloaders, where you create image tags at source.
More or less, yes, but for fonts. And resource hints is the next thing. That's a standard proposal at the moment. It's not actually implemented anywhere, but it basically creates a declarative way to tell the browser's download queue, here, add this resource as something. So as a font, as a script, as a CSS. And the browser then adds the resource to the download queue and downloads it. One more interesting header for this purpose is preconnect, where you can, if you have many hidden resources from a third-party host, you can tell the browser to get, even if you don't know what the resources would be, you can tell the browser to get ready and start warming up, opening connections, open SSL, etc. Currently, no one. But it's an upcoming proposal which basically standardizes previous hints. The hints that are supported is currently you have a DNS prefetch hint, which acts in a similar way for DNS. For preload, there's sub-resource, but it's only Chrome, and it's not really effective. And Obviously, render blocking resources have a huge negative impact, so avoid them if not absolutely necessary. So just a few words, because I don't have much time, about the future. What can be improved with the preloader? So obviously, we can add detection of more resources. Video poster should also be there. We can add better CSS support. So basically, I believe that web fonts can be preloaded. Background images can be preloaded. It's not necessarily trivial, but it can be done. I have an implementation plan. If you're interested, Patrick. We'll talk about it later. And resource priorities, just a few words. There are currently 2 proposals which are more or less on the same spot with regard to defining resource priorities, and they would enable the preloader to be smarter about dependencies and would enable developers to opt out of the preloader without having to dynamically download resources. So it would enable some sort of a markup-based lazy load, etc. But that's not currently, it's not clear what will get implemented from these proposals, if any. And one more minute. What happens when HTTP 2 comes around? Or it's already here, but when it's widely deployed. Because it eliminates the load queue. The priorities that were previously used to just tell the browser which resources, which requests to send to the server first are now sent to the server. So it's the server's job to download these priorities. And we could say that because we're eliminating the contention avoidance, the part where render blocking blocks all other resources, the preloader would have more impact in an HTTP 2 world. On the other hand, server push, at least for first-party resources, you could say that server push can replace all that preloader logic and implement it on the server. So smart HTTP 2 servers that are content-aware can start pushing the resources that the browser needs before it actually figures out that it needs them, assuming they know what is cached or not. And again, assuming everything is first party, which is rarely the case. But so I think that the preloader will continue to be an important part of browsers optimization in an HTTP 2 world, but we'll see about that. So just to sum up, the preloader is an extremely important browser optimization that practically changed the way we think about the loading process of pages. So developers should be aware of it and work with it rather than against it. It can be scary at times. It can seem like it's out of control. But when it comes to performance, it can be your best friend. Thank you.